Okay, so ladies and gentlemen, let's drill down to the level of a person. Suppose we want to maintain an episodic cost associated with when someone suffers an injury. You know, they have to buy a prosthesis. They have to pay out of pocket for some sorts of costs, or perhaps the healthcare system suffers some, a break a leg, what have you. So if we wanted to add not just state-based costing as we have now, cost per year of being in a state, but we wanted to have cost based on an episode, a certain event. How could we do that? How do we do that? I'm sorry? Yeah, you could do a counter, but it needs to sort of hit the costs immediately. So I kind of like the counter idea is an interesting one, but we want to reflect this immediately in the cost. So maybe there's a $10,000 cost or $5,000 cost immediately imposed by virtue of the injury. Essentially we treat it as immediate. They have to go in for orthopedic surgery, and it ends up imposing a cost immediately. So how do we capture that? Well, I'll show you one way, okay? I'll show you one way. And what we do here is, in this transition, suffer injury, what we're going to do is we're going to actually immediately increase a cost in the cumulative cost. So watch this, if you could. I'm going to say main dot cumulative costs, and people kind of liked it before when I spelled this out. Main dot cumulative costs equals main dot cumulative costs plus some cost per injury. Now, I could put this like this, but there's only so much I can stomach as well. Oh, that really troubles me to see these things. I think it probably troubles Dylan just as much. So what I'm going to do is I'm going to show you a better way. Please don't do this. Hard code it. Why not? Why not hard code it like that? We call this hard coding it. Why not do that? It could change. We might want to change our assumptions, and we have to go and burrow down into the model and find all these things. The same assumption, like $5,000, might be captured in many places in the model, and maybe you update some, but you forget to update the others. And there's no obvious connection between them. There's the 5,000 here, 5,000 here. You can't tell if they're logically the same value. Do they come from the same place? Maybe one's 10,000 divided by 2, and the other is some value drawn directly from the literature. But maybe they're the same value, and it's not clear, which one do I update? You can search in any logic. Control F will search for, all occurrences of 5,000, and it will tell you where these are. But maybe somewhere you've divided by 2 and just put it at 2,500, and that logical connection has been lost. It's much safer, ladies and gentlemen, to capture these things as either a parameter in main or as a constant value, sort of like we did with this beta here. Let me show you how you do it with a parameter in main, because this is very common need. So let's go here, up to main. Let's go down main. Okay? Okay. Okay, we're going to go down main, and we're going to drag into main a parameter. Where do we go for parameters here? Into agent, and we're going to drag it in, and it's going to be cost per injury. Okay? And maybe we'll give it a value by default of $5,000 if it's not specified by an experiment. Okay? People okay with that? Cost per injury. I put it in main. Now, ladies and gentlemen, let's go down to person. And at this point, I would like to add in what? Yeah. It's cost per injury, but I need to refer to main. So this is how you do this in any logic. This is an important life skill. Main dot cost per injury. That will refer to it in main. Is that okay? It's that. So main dot cumulative cost equals main dot cumulative cost plus main dot cost per injury. Now, I'd be tempted actually to create a function in main that says increment the cost by this and to call that. And in fact, I can't resist it because every time we do it, every cost we're going to do this for, actually there's a logical set of actions. What am I forgetting here by just doing this? What am I not incrementing that I need to increment? This is actually not done. What else do I need to increment logically? Discounted cumulative cost, darn right, equals discounted cumulative costs plus what? Is it plus this guy directly? No. What do I have to refer to? Main dot discount rate. Discount factor times this thing. Okay, now, as far as I'm concerned, that's adding insult to injury. This is, to me, this is ugly. First of all, I'm going to have to do this wherever I need to add in an episodic cost. I'm going to need this pair of things. Second of all, it's got all these mains littered. Main. Gosh, have you ever seen a sorrier sight? It's terrible. It's terrible. So that to me is a bad smell. It's time to refactor. This stuff, it's all well and good. The logic is fine, but we need to put this in a place that is cleaner. This is the type of code up with which I will not put. To paraphrase Winston Churchill. Okay. Okay. So we're going to wrap this code up. This code is fine. Make sure it compiles. Make sure any logic is happy. And one of the things we should see is actually, if you run this, you should see the occasional jump, probably, in cost. Let's try running it, and then we'll try refactoring it. Write it, make it run, make it write. Okay? So if we do this and we look at costs, there'll probably be the occasional jump up in terms of cumulative cost representing this, representing these injuries. Although it's, I guess, few enough people are obese right now. It's not incurring at a very, very heavy rate. We could look at it's there's an occasional thing there, I think. Yeah, there's one right there. Yeah. Little discontinuities. That's right. If we made it a much larger cost, how could we make it a larger cost? How if it were $100,000 per injury? How could we do that? Well, all we have to do, because it's a parameter in main, all we have to do is fill it in the experiment. Make it $100,000 per cost. How would that change things? Let's run that. Run it. Okay. Here we go. Look at that. Look at that. It's exhibiting almost sometimes quite jagged sort of growth sometimes, yeah. So as injuries are occurring. So in short, ladies and gentlemen, we have captured it, but we've captured it in an ugly fashion. And there's a certain amount of ugliness that we have up with which we have to put. But there's a certain amount of ugliness that's gratuitous. And this is gratuitous ugliness. And so, with your leave, I will excise it. Okay? Okay. Okay. So, this won't take long, and it will leave us healthier for it. Okay. So, ladies and gentlemen, we go to main, we add a what? Function. Okay. And this function is going to be impose episodic cost. And this function will be different from all other functions we've written to this point. This function, ladies and gentlemen, will need some information to do its job. What information is that? Yeah, it will be called during the entry. And what information will it need to carry out its stated mission? It will need to know how much to impose. So, by the way, is this impose episodic cost? Is that just an action, or is it going to return a value? No, it's just an action. It's just going to do something. It's going to change those discounted costs and undiscounted costs. It's going to modify them. It's going to impose them. You can see by the name, it's imposing it. And it's not returning any value. It's not calculating value. It's just imposing it. It's changing something. Its job is not to compute something, not to calculate something. Okay, so we're going to go to the argument section. And we're going to have it take an argument that's cost to impose. And what type will it be? Will it be a Boolean? Will it be an integer? Perhaps a string or a diabetes state? What will it be? It'll be a double. Dylan, was that your utterance, or did it come from the crowd? Okay, that's good. I try to read, people's comfort, and I didn't know if it was you. Yeah.
I didn't even hear anybody speak, so I was figuring out when you asked me if I said anything. No.
Okay. Well, maybe it was the ghost variable we added. Okay. So, for the function body here, what will a function body do? Okay, well, we just have to go back to person and retrieve that. It's going to do what this does, but it's going to do it in a more beautiful way. Trust me. So, where this is in place, what are we going to have it do? Boy, am I glad to access that. Gone. We're going to have to call main dot what? Here. Main, and that name of that function, impose episodic cost. And what will be the cost to impose? Main dot, what it was called, the cost per injury. Boom. Done. Boom. Okay, that's, will you at least admit that that's less ugly? Indeed. Okay. Jeff looks unconvinced. Okay, so now let's go back to main. Let's go down main. Okay, you can say go back to main too. I mean, that's, yeah, as long as you don't say go up main. Okay, so this is what we have in place for this. And now in this code, we're going to paste in what this did, but instead it's saying cost per injury, it's cost to impose, it's the information given to us. So we could call this function now on all sorts of different places. Maybe one is for an injury, maybe another is for an operation, maybe yet another is for a, some sort of one-time drug that's required from different places in the model. They could all call this function and be hidden, this ugliness. Look, there has to be ugliness in the world, but when it comes to these sort of things, by hiding a function, you don't have to see it most of the time. You only have to see it if you want to see it. If you have to see it to do the job. But for the most part, you want to see this stuff. This stuff is just ugly. So we hide it and we put it in one place so that if we need it, we can keep on reusing it. So now we can strip out all these mains, because why am I stripping these out? It's not out of spite. We're already in main. We don't have to say main. Okay, there we go. Compiles, builds. The world is a better place for it. That is the type of code up with which I would not put. Okay. Functions are your friend. This is one of the things I'm trying to, I don't know about other things. Those quality of life tables, I don't know that you feel those are your friend. But functions are your friend. Take a look at this, folks. Oh, I mean, it's a thing of beauty that if we had all these other costs imposed episodically, all we'd have to do is call it impose episodic cost, tell it how much to impose it. It'll take care of all the details of, it knows which stocks to increment and by how much, and we don't have to worry about all those god-awful details. I mean, there's so many things. We don't want one portion of the model to have to know all the details of the other. And so there's so many things going on. You don't want to have this thing to have to know all the names of the stocks up in Maine. Instead, you just call it and you tell it, do its job, buddy. And it does its job. I guess here you'd say, do its job, might. Right? And it does its job. Yeah. Good. Sure. Most certainly. So impose episodic cost function just does an action. Arguments cost to impose, which is a double. And here's the function body. Now, I have to tell you, I would use further brevity with this. I would prefer to express this in briefer forms, but I understand the fact that not everyone would feel comfortable. I do cumulative cost plus equals cost to impose. Just got a cumulative cost plus equals this thing. But not everyone shares my aesthetics. As you can tell by my dress. Okay, so is that okay? Good. Yeah. Okay, that's a very good point. I love making things explicit. So if you wanted to do this, that would to me would be a good thing. Sorry? Yes. This everything is clear. Everything is clear. And that's a very important principle. I put lots of parentheses around things because I want to be clear. And I've worked with student code where they have not done it, and it's caused these terrible bugs. It's horrible. All because they didn't want to have. They were too stingy for a pair of parentheses. I mean, man. They're available for free. Okay, so people okay with that? Now we have this thing, we could call it from many places, it would do the job, we wouldn't have to worry about how it does its job, that's all hidden, we just say impose an episodic cost, boom, impose $2,000 here, $5,000 here, $20,000 there, and it does the job, we could use it in many places. Okay? Okay, so that's episodic costs. Now there's a question about cost offsets, and you're going to have to help me understand the interpretation of that term, because that isn't one I hear in Canada a lot. So when you say a cost offset, help me understand what the concrete meaning is.
Also, if somebody has a particular intervention.
Right. Okay, so you're talking about like an intervention cost?
Well, whatever. That's just what came to my head when you asked.
Yeah, because there are some costs that would be associated with incentives or costs to impose for intervention, and what would be the best way to capture them? An example model it provides you does provide a way of capturing them. So I guess it depends a little bit on the nature of those costs. For example, if it's on a per person basis, you might impose those costs at the time of intervention on that person. Or if there's an ongoing cost for that person being in a program, you could capture that by them being in a certain state, which represents the fact that they're enrolled in the program. So you'd have a state chart. Are they intervened upon or are they not intervened upon? And you could have a similar cost accumulated there and added into the set of all costs. So I think that those sorts of costs should be able to be folded into either episodic costs or costs associated with being in a state if we had to do it that way, by using state charts to represent their intervention status. I don't know if that's an entirely satisfying answer. Okay. One thing we haven't done is actually explicitly shown how we might capture an intervention. Do you want to do that? You want to do that? Okay. Okay, maybe we could deal a little bit with this issue. Okay. Great. Okay. So let's go take a look at the situation with a person. On whom are we intervening? We're intervening upon persons. So we could simulate interventions of a number of different types here. I think before we do this, so we can see visually the impact of an intervention, I would like you, ladies and gentlemen, to make all the people who are diabetic appear in red. How would I do that? The afternoon. It's tiring. Okay, so we're going to go to the little man in the presentation of a person, and here we go, and we are going to look at their what? Appearance, and we could look at their bill color, and what do we want it to be set by? Well, there's many ways to do this. We could do is state active, so, or diabetes state chart, is state active of diabetic, and if so, make them red, otherwise make them black. That'd be okay, wouldn't it? But I'm going to ask you to do another thing, because this is a very common need, and it's more general. Yeah, I know what you're going to say. You're going to be thinking the last time you said we're going to do it in a more general way. Then we got all fouled up. Okay, so let's, but I'm going to do it in another way. I mean, that's not too bad. So we're going to impose a, ladies and gentlemen, if we want things to change when we change states, so we want to use one color for one state, another thing with another state, how have we done that in the past? We've used a what? If we wanted a hazard rate to change when we change states, how have we done that? We've used a variable. A variable. Have we not? Indeed. So ladies and gentlemen, let's add a variable called color. Okay? Yeah, you know where I'm going with this. You know where I'm going.
I just saw the U and I remember
Yeah, indeed. Okay, now what is the type of this variable? It is other. And what is that type? Indeed. And were it only so. I compile, and it's going to be an unhappy camper. It says color cannot be defined to a type. Oh man, okay, so what has this got to be? Well, guess what, folks? Java defines color without a U. It takes the U out of color. So we need to go back to color, and we need to declare it as a color. It's a set of all colors. It's kind of the concept of color. It's colorhood, right? Things with a capital C, we try to use it to define a class. It's kind of describing colorhood, just like capital P personhood. The various option lists define diabetic statehood, the different possible values of it. They describe all possible values. Okay, color is alas not available, but we'll say color. And that's good. That's good. Maybe we'll define an initial value of black. Okay. And we will go now. So now suppose we want when they're normal glycemic to be green, and then when they're diabetic to be black, or to be red. How would I do that? Tell me what to do. Okay, entry action. Good. First thing we'll do is we'll assign to color. We'll assign what? Green. Green. Okay. Now, by the way, you can spell them. You could spell it in capital, or you could spell it all lowercase. You just can't spell it with a U for the class, okay? Okay. And then for diabetic, it will be red. And now how are we going to realize it? Is this going to be enough? Is this going to change the colors by themselves? By assigning this variable? I think not. What more do we need to do to affect that change? What more do we need to do to actually cause the color to change? What more do we need to do to accomplish our goals? Now we have to go to the little man. And we have to tell him about that his fill color is what? Color, the color variable. Okay? Boom. Done. Okay, who wants me to rehearse that again? Good, good. Okay, so I'll do this from this. So what we did is we added a variable. We called the variable color with a U. We declared its type to be other. Well, it wasn't in our standard list, so therefore we called it color. We noted that it was spelled with the dictate, the American Imperium. Capital C-O-L-O-R. color. We then characterized its initial value to be black, although that turned out not to be particularly germane. We went to normal glycemic, and we set color, the variable, equal to green. We went to diabetic, and we set color, the variable, equal to red. And then we went over to the little man, and we set the fill color in the appearance section to be given by the variable color. People okay with that? Yes, Dylan.
I just want to point out as a side note here, never underestimate the value of color and a good visualization. Sometimes when you have, let's say, thousands of agents on your screen and you're trying to figure out, why it's misbehaving, or you want to make sure that something is working the way you expect, if you color them according to the different states they're in or some other salient feature, you can basically look at it and be like, oh, at a glance, this is doing what I expect.
Or it's not, yeah.
Or it's not. And I use that technique over and over again to diagnose problems, because sometimes that's just the fastest way to do it. Your brain is evolved to pick out visual patterns. Use it. It's a tool you have in your toolbox.
Yeah. Good. Okay. So we've just colored them. Now shall we put in place the intervention? Okay. Good. Okay. Great. So I'm going to stop this.